Hi, my name is Herbert Taylor, and I'm here to do my video presentation on electromagnetic wavelengths. What are electromagnetic wavelengths? Electromagnetic wavelengths are a form of energy that have both electric and a magnetic field. Electromagnetic wavelengths are different from mechanical waves. They can transmit energy and travel through a vacuum. There are different types. They have different uses and functions in our everyday lives. Most important of these are the visible light, which enable us to see. There are different types of electromagnetic wavelengths, such as the radio wave, the microwave, the infrared, the visible light, the ultraviolet, the X-rays, and the gamma rays. Here is a diagram giving you a picture of the different type of wavelengths, as you see here. The magnetic wave spectrum, radios, microwaves, infrared, visible lights, ultraviolet, X-rays, and gamma rays. Radio waves are the longest of the wavelengths. Radio waves can travel from a foot to several miles. Radio waves are often used to transmit data and have been used for all sorts of applications, including radios, satellites, and computer networks such as the Wi-Fi. Then there's microwaves. Microwaves are used to cook food and transmit information. Microwave usefulness in communication because they can penetrate clouds, smoke, and light rain. The infrared. There are two types of infrared. There's the far and near infrared. The near infrared waves are closer to the visible light in the wavelength. These infrared lights are used to change your channel with your TV remote. Then the far infrared are used by the military for thermal heat imagery. After the infrared, you have the visible light, which is the most important of all wavelengths. It can be seen with the human eye. This range of wavelengths is from 390 to 700 megamites, which corresponds to the frequencies. Then there's the ultraviolet. The ultraviolet wavelengths have the next shortest wavelength after the visible light. Ultraviolet rays are from the sun that can cause sunburn and cancer. And we're protected from the ultraviolet through the ozone layer. After the ultraviolet, you have the X-ray. The X-ray is shorter than the ultraviolet, and it can also penetrate through soft tissue, skin, and muscle. The X-ray is used for determining fractures in bones in the medical field. The X-rays are discovered by the German scientist Wilhelm Regenton. They can penetrate soft tissue, like I said. After the X-ray, you have the strongest but shortest, which is the gamma ray. The gamma ray is used to treat cancer and also used for detailed medical imagery. The gamma ray has been a miracle to modern medicine. Interesting information about electromagnetic waves. Based on the pilot study and the vivo environmental exposure, waves promote and develop infertility related to premature capacitation outside the vaginal tract. Basically, it's saying is when we go get X-rays, we have to be protected by a lead vest in order to have a healthy embryo. The rays can be damaging as well as being helpful. Exposed to semen, this particular frequency may also boost the capacitation of hyperactivation and spermatoza of the vitro prior to conducting assisted reproductive therapies, which I found in the Bpcc library. Another article presents a review of concepts to provide and microwave researchers in-depth information of electromagnetic techniques for microwaving imaging, sensors described in recent developments in these techniques for women with breast cancer. And here is a copy of my references that I used to come up with my information. And that is the end of my presentation. Hope you enjoyed.